In our SPOJ series, the next question is almost shortest path. In this problem, what we essentially need to do is that given a graph, there will lie a source and destination, and there will exist a path from the source to destination. There will exist some multiple such paths. There will be a shortest distance between the source to destination. There will be some multiple paths that give you this distance, shortest distance from source to destination. What you need to tell is not that path which is shortest, but the path which is second shortest, kind of. And so the approach to solve this question is to first find all the shortest path, then delete all the shortest path. Does it make sense? No. Delete all the edges that occur in any of the shortest path. So in a way, that is how you are going to remove uh, or basically truncate some edges and nodes from the given graph, so that the edges that you have just removed uh, are the corresponding edges which creates the shortest length path. So for example, in this graph you will remove something like S2, the two highlighted lines which are shown as bold. Those two path containing three edges and two edges respectively. Three edges wala is 1 2 1. You will remove these three edges, and nodes also, the nodes that lie right between this path. And the other path I'm talking about is 2 comma 2, which contains two edges of 2 2, right? So these two paths. Now how to delete these paths? So I'm saying create a graph, create a reverse graph, do a Dijkstra first of all by creating normal graph, and then Dijkstra gives you a distance vector. So you know a distance of d, which is the minimum possible distance of d, but you will start from destination. Then you see all the possible neighbors of d. You already have the minimum distance of d. Now you see the neighbor. If the value for neighbor in the vector, which I essentially mean is the d of neighbor, which is the minimum distance of source to neighbor, is equal to the minimum distance of source to destination, whatever was this, minus this edge weight. It means that till this neighbor you came from source using this weight. Okay, this is the cost that you have taken to come to this. Now there is one way to come from this neighbor to the destination using the edge weight, which is something, right? And that edge weight plus the distance that you've taken to come at this point, the cost you have taken to come at this point, plus that edge weight gives you a value which is equal to the d of destination. Basically, yeah, that is the shortest path for destination, which means this node surely lies in the shortest path, because I just found the shortest path from source to destination via this node, because source to this node is some, let's say, x, then this node to destination is something y, and then x plus y is equal to the shortest path. So yeah, I need to remove this, and then what I pass to the like this person is that okay, you are deleted, but again, like what we will pass as, we will pass d minus this edge weight. So this is the total distance to, yeah, like reach this point. Then you see again, you do same thing for his neighbor. So for his neighbor you will ask that okay, this is my d of me, basically the minimum cost to reach myself, minus this edge weight which neighbor I'm traversing. And then you see the distance, minimum distance for that neighbor, if that is equal to this point, this value, which is total distance to reach this point, which is the minimum distance, okay, d of me minus this edge weight, which means that node, the distance of that node from source matches with this. It means that okay, you came to that node first, let's say x dash, and then you came using this edge weight of e from x dash to x, okay, and that total length x dash plus this e is equal to d of x, okay, which is the we are sure that x lies in the shortest path from source to destination. X is just going to removed, and x dash we will need to remove also, because this is also one such node and one such edge and one such path from source to destination having minimum weight. So that is what we will do. and we will remove all the, and this we will do till when, let's say this x got removed, then this we come to this x dash. Okay, we are sure that this x dash is needs to be removed because the, so this the cost to reach this x dash is 1, edge weight is 2, which gives you 1 plus 2 3, which is the minimum distance to reach this point, which occurs in the shortest path, right? Or that node is removed, so this node is surely going to remove. So what you essentially pass basically d of v minus 2. So you pass, let's say, one, or the you call on it's his neighbor is directly source, and then you ask source, okay, I'm going to remove, like this node says I'm going to remove, he just checks if this neighbor has to be removed or not. But we know that this is source, but the algorithm does not know this is source. So algorithm will run for this. He will check that, okay, yeah, if the distance becomes 0, so just stop. Okay, so that we can do. So that's how similarly we'll do for this node. This checks like 2 removes from this is minimum distance for this is 4, 4 minus 2 is 2, if that matches with the dis of this, which is d of this is equal to 2, so that matches. So this node is going to delete. He will pass on the next node neighbor, and he'll ask him key my was 2 minus edge weight, which is 2, equal to 0. Okay, now you just need to just match that d of that node is equal to 0 or not. But yeah, when it becomes 0, we know that we already reached the source, or there cannot be other way around, which you should not think about it, because distance d should be greater than, yeah, 1. So yeah, that's how you will go, and you will create a new graph, like, okay, how I'm deleting edges, create a adjacency vector as adjacency, like set, use some set kind of thing, which you can use set dot arrays, and yeah, delete that, and then yeah, that should be fine. And what more? Hmm. After the whatever you graph you read, and then do a extra on that graph, like, yeah, deletion is the only option, right? Because set dot erase is also a costly operation. First, let's do that, and we'll see what needs to be done. Or yeah, or we can modify the edge weights to something like, yeah, I feel modifying the edge weight is better. You don't need to delete. Hmm. Obviously, you're traversing on edge. Modify this edge and then call for this part. Hmm. Modify would also work, and we don't need to think now anything else more. So every question has a stop thinking point where, yeah, sometimes it's like very big. In this it was moderate, I would say. NM, then while q size auto f is equal to q top. I'll take out the first like yeah the smallest distance element and explore his neighbors and see if that distance of neighbor of let's say I of 1, because this I0 means like okay you need to store distance also, so that can be stored like that I feel. So that is the distance actually. So what can be done is v is equal to I of 0 and e is equal to I of 1, that's edge weight, and see that if d of uh, actually like in this u is equal to f of 1, and yeah d of v is equal to d of u plus e q dot push du dv comma v. There is some optimization which says that if your du became lesser than f of 0, just continue because now this is not needed as such. Okay, this is that f of 0, yes I'll take that. Now this would create a d vector. Hopefully this will create a d vector. What needs to be done is that reversal or start from that. You do a dfs from d to just change some edge weights. In reverse graph you will do that, then you can calculate it by extra. There would be test cases also. So one basic handling for test cases is you do I dot erase. Now du is yeah dv changed. How so? dv got changed or edge weight got changed? dv is not changed till now. Edge weight has got changed. You can do a Dijkstra. So now I don't want. I need Dijkstra for dv, right? But I want to do some like dry concept. You know dry concept. DRY stands for don't repeat yourself. So I'll make that Dijkstra over here. Now, yeah, that's how you will go about it. and I will provide you graph which you need to do the extra. In source I'll provide you and I'll provide you the graph. You will return me a vector and yeah, for now I don't want as such any return of vector. Just want you to just fill the D vector of graph basically. Should be fine. I don't know exactly, but yeah. So then, as you call on Deitch of source to graph, then you call Deitch from destination to RG reverse graph, and yeah, that's how it goes. You print C out D of S, and then BFS is main thing. Auto IN G of SV and I. Okay, so basically this is the reverse graph. Um, or I in SV if I is not equal to paint. There are no cycles as such. Not visited. Should I keep track of that? I don't know. You can. You may. So, so if sorry, yeah. So if distance of what I, not exactly I, but I of one, I zero is exactly equal to distance of SV plus I of 1, which is edge weight. Really? Are you sure about that? Plus I of 1. So yeah, that's how I go. That's how you go, man. So this is the short distance and this is short distance. This is the I1. So yeah, call on DFS, man. Call on DFS, man. From I of 0 and yeah, that's how I did. And before this or after this, don't know, but change the edge weight and doesn't matter because yeah, because in RG there is no connection from that to that, hopefully, or if it is, yeah, there will not be. Okay, so change that. I1 is equal to 1 in 9. No, just do, no, no, man, like yeah, surely do 1 in 9. Uh, yeah, 1 in 9 should be fine. Max, don't think about it too much. But if it, yeah, gathers up, let's say there are 1,000 nodes having 1 in 9, that would be an issue. To 28, man, there would not be more than 1,000 nodes. There are only 500 nodes. 1e8 will work fine. Okay, would work fine. And there, yeah, this P is very small outside. Why are you thinking so much? Yeah, but P is small. 1e3. There are 500 nodes. Yeah, that's it. So yeah, 1e8 will be fine. And or does it actually change the thing? Yes, it should. It should. Yes, it should. It should. It should. Yes, it should. It should. It should. Yes, it should. Yeah. Yes, it should. Ampersand. Apply ampersand. Ampersand. Yes, it should. It should. It should. You call on DFSI 0, and then you call on that. Then you see the neighbors, then you see this. This is true. Then you do ace, and then you go to this. Make sure that that is not a starting point, right? Otherwise, what you will do, you will yeah. Why not? Why not? Even if it is starting point, what is an issue, man? You need to delete that as also. Let's say I0 is starting point actually. So 0 plus 2 is the distance of that. So that comes, yo, bro, that comes in the path of shortest path. So you delete that. You delete that by doing this. So even if I0 equal to 0, you do that. But after that, you don't need to take care because if your SV or I0, you call them 0. So you check the neighbors of 0, right? And there will be some neighbors of 0. Essentially, there will be no neighbors of 0. Like source, who has like an incoming edge to source? That would be the neighbor from source because this is the reverse graph. Now, after having that, yeah, who has incoming node to the source? You have that, then you see df 0 like df 3 is 0, then df that would be okay if someone has an incoming towards source, and then how do you reach that? That would be 1e9, man. 1e9. Yeah. So that is what I'm saying. Ki there should not be any other neighbors of the source first of all, because this is the reverse graph. In normal graph, there are neighbors of source. I know that source from source you can go to some places, obviously, but in reverse graph that means ki can some places go to source. Even if that's possible, then what is the shortest distance from source to that node? If it is something, and will it match with something like 0 plus I1? It will be weights are positive. The distance has to be negative. Can the distance be negative? No, no, it will automatically stop. Yeah, don't do this. Yeah, yeah, it should be fine, man. Should be fine. Should be fine. Just handle double zero in the end. How will you handle that double zero in the end? I don't know exactly because they're not providing the test case, man. They're not providing you any test cases. It's just a kind of a absurd while loop which runs forever. And if n comma n is zero, right? How do you see that? One way of doing that is c in n int m. C in start from m, and if n is equal to 0, you break you break out, you do this, and then you do yeah, that's should fine. So yeah, just declare everything in a nicest manner. Dot h should define let's go e for for e I plus plus, there is semicolon, const e nx equal to 1.526. Oh, 1.5 is fine, man. There are just 500 nodes. I0. What? Watch. T of SV. What? Inch of inch. Inch of inch. That's why I'm right now. vector. Are you sure, man? Which statement, man? G dot size. Take G dot size. Array does not have anything called size, man. So have int n over here. So now you can actually do n plus 2 plus g of erase plus d is a vector. Acha. There is no point of making a d a vector actually, because we are using it in a way. But yeah, I don't understand why do competitive programmers are so obsessed with arrays. I know that it's somewhat faster than normal vector. Who? What's this, man? F of 0. Okay, f of 1 side. But you already had u. That makes it more. Each of inch. Inch of inch. What is an issue, man, in this now? Vector of inch. Okay. E is not declared. Why so? No, now it is declared. No? Slow compiler. Any other erase? Acha. G of I dot erase. A vector erase. There will be an issue with this. What? क्या है भाई? Okay. Should not be. If it is, then how many? Yeah, we could have done like some error. Even when you don't know error, how can I know the error? Zulu, where's C++ man? Okay, how to go about this? Oh shit! It was g of I dot clear. I mean, S S. What's an issue with this man now? DS equal to 0, right? Does he don't know about S or what? Inch of inch. अरे यार. What? Inch of inch. Int s. D of s. This line has an issue, right? 51 line. 51 line. D of s is not defined or what? D is not defined or what? D is also there now. That's an issue, man. Man. Let's call it destination. Destination. centrifugation, and colon dextra destination source. Yeah, that's fine. She fine. Destination. Wow. What do you mean by this? I would like to do this. Let's say even if we repeat ourselves in a way that we just need to change only this RG and dig2 dig1. It's called dig1 dig2, and yeah, remove that, get rid of this SRG DRG, right? Man, what is this? Yeah, what should I do? Should I remove this is fine for you. This is fine. Alright, till this point even. But I'm not even running anything, I'm just reading input for each test case. Look, command terminated. Why you are terminating my commands, bro? Are you not really? I'm not calling on this, man. DFS of DSF D of S. How you will know D of S? Yeah, but listen, man. Like, look. Let's do this. Let's do NX. Bro, this is some serious stuff. What is this? Like nothing. I'm running nothing. Neither DG1, neither DG2, neither DFS. Still, still you have a problem. I'm not reading input correctly. S des minus minus, or even you are 0 0. Ah, you are 0. I feel. Yeah, man, you are 0 0. Remove this. Remove that. Okay, fine, 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 fine. Dig1, dig2 was not declared. Really? Really? Aisha? Question had zero indexing, man. I don't. Okay, when do you have to return -1? Okay, okay. Yeah, in that case, it would be like 1E8, man. And then previously declared here. Again declaring there. ठीक है 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 5 to 4, but why? Why 5 to 4? This 5 is fine, I know, but -1 and the 6. Yeah, G of I dot clear. Why am I not clearing the stuff, man? Clear the stuff. Again? Should not be that. Clear the stuff. Like crazy. Yeah, but can be done over here. Yeah, I think I removed it from somewhere. No, you not did not remove it from somewhere, but yeah. Try and implement this everywhere. Why you need to do it everywhere, man? One difference. Yes. Yeah, why 5 and 4, man? Why 5 and 4? 5. 4 तो I think ऐसा actual distance भी नहीं होगा. Really? For this graph, who will just see this graph, man? There's a node from 0 to 1, there is 0 to 2, then there is 0 to 3, 0 to 5, 3 to 4, 4 to 1, okay, 5 to 1. It's a serious cycle. 3 to 0. Even, yeah, I can draw it in this now. So 0 you have 1, and 0 you have 2, 0 you have 3. 3 you have 0 also again. And from 3 you have 4, and then 4 you have 1, and then from 2 you have 5, something 5, and 5 has 1. 0 there was 1. अरे बड़ा अजीब सा ग्राफ बनाया again. 0, 1, 1 goes 4, 4 goes 3, 3 goes 0, 1, 0 goes 2, 2 goes 5, 5 goes 1, 3 and 5 has no relation. 4 also goes to 1, man. Everyone is going 1. 4 going 1, 5 going 1, 0 going 1. पता नहीं यार क्या है डेस्टिनेशन क्या तेरा 0,1 that is 1 actually. अच्छा इसके बाद तूने हटा दिया ये वाला रास्ता कुछ है कैसे बना दिया भाई 0 से 2 जा 2 से 4 जा 2 से 5 जा 5 से 1 जा why are you doing this अच्छा बट ये करने का कॉस्ट भी तो हो कुछ 0 से 2 जाने का है 2 2 से 5 जाने का है 3 5 से 1 जाने का है 1 so this looks like 6 but what about 0 से 3 जाने का है 3 again 3 से 4 जाने का है 2 अच्छा तो 4 कैसे आया था 0 to 1 कितना था 1 था 4 कहाँ से ले रहा है भाई तू रास्ता तो हट गया नया रास्ता कौन सा जोड़ दिया somebody come to 0 also ना 3 is coming to 0 हाँ अपडेट नहीं होना चाहिए भाई मान ले कर दिया तो विजिटेड बना लूँ क्या विजिटेड बना ले ब्रो विजिटेड बना ले मैं कह रहा था यूट्यूब चैनल 511 अरे वाह 511 और छोटा हो गया ये you're really giving me the shortest path man पता नहीं यार मतलब क्या इशू आ रहा है इसमें try again or what oh man visited का कुछ होना नहीं चाहिए वैसे तो unable to process request क्या भाई तुम्हारा सर्वर डाउन हो गया क्या 514 अच्छा यार 1 की जगह 1 की 9 आना चाहिए था और 4 की जगह 6 आना चाहिए था और जो 6 है ना क्योंकि is there any issue oh man like seriously did you one did you two Shama, अच्छा I think ना you really think नहीं यार से पड़ता 1 8 यहीं पे कुछ गड़बड़ हो रही है डीएफएस में या तो ये ठीक से विजिट अनविजिट कर नहीं पा रहा एक काम कर सकते हैं डीएफएस के बाद तुम्हें जो ग्राफ मिला वो ग्राफ दिखाओ ना एक बार रिवर्स ग्राफ दिखाओ हाँ उसमें कैसे जा रहा है वैल्यूज मतलब उससे आइडिया मिलेगा अभी डी वेक्टर यू कैन प्रिंट आउट बट आई थिंक लाइक जैसे ही तुमने यहाँ पे वो कर दिया बार रिवर्स ग्राफ अगर आइडिया मिल जाता थोड़ा सा तो सही रहता ना पहला टेस्ट केस रहने दो अब ठीक है जो चीज चल रही है उसको रहने दो जो चीज इशू कर रही है उसमें देख लो एक बार आई डोंट नो यार कहाँ पे है इसको यहाँ पे ले चल टेस्ट केस प्रोसेसिंग तो यहीं पे सही होती है 6 8 को रहने दे बाकी सब हटा दो अभी केवल ये वाला चलाएंगे हम ठीक है ओ डल 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 कितना टाइम हो गया काफी टाइम हो गया 45 मिनट्स फॉर दिस क्वेश्चन डोंट नो मैन लाइक प्रोसेसिंग अब क्या दर्द हो गया इसे ई वाज नॉट डिक्लेयर्ड I0 32, 33, 32, 33. डिज तो है भी नहीं। इसे रन नहीं हुआ थे अभी यहाँ पे भी नहीं हो रहा। यहाँ पे कुछ इशू है, आई थिंक रन नहीं हो रहा है यहाँ पे। ओके, देयर इज नो नेटवर्क। वीडियो रिकॉर्डिंग चल भी रही है, नेट तो आ नहीं रहा मेरा। लॉजिक यही है यार प्रॉब्लम का, अब कितनी बार बताऊं लॉजिक। जस्ट ग्राफ बना के पहले डेक्स्टर लगाया फॉर एक्स, ये हुई ना अच्छी बात। फॉर ऑटो आई एन जी ऑफ आई एक्स ऑफ जीरो एंड एक्स ऑफ वन प्रिंट करा भाई। लगाया, मिनिमम फाइंड करा, मिनिमम वाले सारे हटा दिए, दोबारा डेक्स्टर लगाया और ये कुछ आ रहा है। हु विल एनालाइज दिस? किसके लिए ये पहली बात। आई प्रिंट कराओ। आई जीरो होगा ऑब्वियसली, जीरो के लिए वन जाने का। अभी भी तुमने वन छोड़ दिया तो फायदा क्या हुआ भाई। पहली बात तो रिवर्स ग्राफ चलाना है ब्रो। और डिज टू में रिवर्स ग्राफ चला रहे हैं। जीरो से वन जाने का रास्ता थ्री छोड़ा है तुमने, डायरेक्ट रास्ता छोड़ दिया क्या। जीरो से थ्री जाने का वन छोड़ा है, ठीक है कुछ भी हो। वन से जीरो जाने का इनफाइनाइट छोड़ा है, बनाना ही क्यों है। अच्छा बना दिया, ठीक है तुमने वो, सॉरी इनफाइनाइट नहीं, वन एट तुमने ये यही तो ग्राफ हटाया, यही तो एज हटाया हमने। मतलब हमारा काम तो हो रहा है बेसिकली, एज के हटाना था हमें। तो क्या ये एल्गोरिथम सही नहीं है? एल्गोरिथम तो सही है, वन से टू से फिर वो देखना है। अभी मेरे को इस ग्राफ के अंदर वन से जीरो जाना है, ठीक है तो वन से मैं कहाँ जा सकता हूँ। जीरो जाने का एक डिस्टेंस ये है, ठीक है जो कि नहीं लेंगे। वन से मैं फोर जा सकता हूँ, वहां तक जाने का डिस्टेंस वन है। फोर चले जाऊंगा मैं किसी तरह से। फिर फोर से मैं जीरो कैसे जा सकता हूँ, फोर से मैं थ्री जा सकता हूँ, डिस्टेंस टू से, ठीक है जो भी आ जाएगा। थ्री से मैं उधर जा सकता हूँ, तो थ्री से मैं उधर जा सकता हूँ। फोर से थ्री गया मैं टू से, ओके। थ्री से जीरो गया मैं, थ्री से जीरो भी आऊंगा मैं थ्री से, ठीक है। सो ये तो रास्ता बन रहा है छः का। ओ आंसर तो छः आ रहा है इसमें। अब ये क्या सीन है भाई, फिर तो ग्राफ क्लियर नहीं कर रहे तुम। अगर ग्राफ क्लियर कर रहे हो तो तुम डी क्लियर नहीं कर रहे। तुम डी क्लियर कर रहे हो तो तुम आर जी क्लियर नहीं कर रहे। आर जी क्लियर नहीं कर रहे। आर जी क्लियर क्यों नहीं करा तुमने? आर जी सबसे ज्यादा इम्पोर्टेंट है यार, मोर देन ग्राफ आर जी इम्पोर्टेंट है। आर जी कैसे भूल गए भाई। सो 1 ही 9 आएगा उसमें, एंड जब 1 ही 9 आएगा तो या जो भी है 1 ही 8 है कि 1 ही 9 है, कौन गिनेगा इसे। कितनी जीरो है इसमें, एक दो तीन चार पाँच छः सात आठ जीरोज है। हाँ मतलब ठीक है 1 ही 8। अब ये भी बात है, हाँ ग्रेटर देन इक्वल टू 1 ही 8 करते हैं, ठीक है इतना कहाँ मिलेगा। फाइन, क्या कर लिया भाई ये। select this, paste over here, paste over here। तो क्या है ये, वेयर इज व्हाट इज दिस मैन, व्हाट इज दिस बिहेवियर। अब ऐड वाला सेक्शन नहीं आएगा, राइट। व्हाट इज दिस यार, चलो छोड़ो से। टेक दिस, Take this and sum this up. Put the Karani into DS. This is when a submit. चलो 40 मिनट फॉर दिस प्रॉब्लम यार. अब जस्ट एक अच्छी चीज के चक्कर में तुम इतना टाइम नहीं दे सकते, राइट? देयर वाज ओनली वन गुड कॉन्सेप्ट इन दैट कि या जो करा हमने कि डाइक्स्ट्रा वन डाइक्स्ट्रा टू बीच में डीएफएस फॉर रिमूविंग द एजेस ऑन. रिमूवल का हमने आंसर मतलब ऐसे कर लिया कि वी आर नॉट रिमूविंग, एक्चुअली हम अपडेट कर देंगे बड़े नंबर से, ठीक है? सो या दैट शुड बी फाइन. एनीथिंग एल्स? लाइक नॉर्मल एक्स्ट्रा दे देता तो सही नहीं लगता ना. सो दैट्स व्हाट आई थिंक. इसमें ट्रैवलिंग कॉस्ट में नॉर्मल एक्स्ट्रा था, सो वी डिडंट डू दिस. दैट्स व्हाई वी मूव टू ऑलमोस्ट शॉर्टेस्ट पाथ. सो यही है, थोड़ा सा तो क्वेश्चन में मसाला होना चाहिए. एक्सेप्टेड. You just solved this problem. Nice, man. But yeah, we have to do faster debugging kind of stuff. चलो अभी इसको खत्म करते हैं. Okay, bye.